Okay, so today we're looking at arithmetic sequences. So our learning intention is to gain the knowledge of an arithmetic sequence and its components. So we'll be successful if we're able to identify what an arithmetic sequence is. If we can calculate the common difference and we represent that difference with D by the letter D, know or establish a recurrence relation, understand what the recurrence relation is, and use the general term of arithmetic sequence and use the formula Tn equals A plus n minus 1D. And this, from memory, is on our formula sheet. Which is on page 1 of our formula sheet. Okay. So, in an arithmetic sequence, each term is a constant amount more than the previous term. So, 5 plus 5 equals 10, 10 plus 5 equals 15, 15 plus 5 equals 20, 20 plus 5 equals 25. So the difference, which we represent by the letter D, is called the common difference, and in this example, the common difference is 5. The common difference in this example was equal to 5. Okay, and we can figure that one out by just going 10 minus 5, yeah, or 20 minus 15, yeah, the following term minus the previous term. A recurrence relation is an equation that defines the term of a sequence by referring it to its previous term. So for example, this n, so let's say I want the third term, so T3 is equal to T2 plus the difference. Yeah, so that's how we'd read. So whatever term, so that maybe let's say the fifth term is equal to the fourth term plus D, plus the difference. So therefore the difference is the term that we have minus the previous term. So if A, so this is not if A, right, was the first term of an arithmetic sequence, so for example, A in this situation would be 5, the general term of an arithmetic sequence is your term that you want, so Tn, or yeah, the term that you want is equal to A plus n minus 1D. So, and as I said, it was on page 1 of our formula sheet. So, for example, if I want my fourth term, so that's 1, 2, 3, 4. So if I want that term, it is the first term, example A, plus the previous, so the 3, so T was 4, so 4 minus 1 is 3, 1, 2, 3, times D. So 3 times 5 is 15, 15 plus 5 gives me my fourth term of 20. Yeah, so the nth term is equal to the first term plus n minus 1 multiplied by the common difference. Let's do some examples. All right. We want to find the value of the pronumeral of these. Okay. Now remember, so what I'm trying to figure out is I want to find out the difference so that I can add the difference. Yeah. So the common difference in this example would be 9 minus 5, which gives me 4. So therefore, in this situation, y is going to be the previous term, 9, plus the common difference of 4, which gives me 13. Looking at this example, I have x being on the inside. So the common difference in this case is going to be x minus 45. Yeah, x minus 45 will give me d. But d would also be equal to 99 minus x, that number minus the previous term. So now I have an equation, so if I bring that x over here, I get 2x and I add 45 to that, gives me 144. Divide by 2, x equals 72. Yeah, so that number is going to be 72, or that term is going to be 72. Using that same idea of finding the common difference, I'm going to do the same here. So I'm going to have my middle term, 5k plus 2. I'm going to subtract the previous term, and that's going to give me d. Yeah, but d will also give me, I can find d by also doing 21 minus 5k plus 2, the previous term. And now I have an equation. So really I've got 5k, 2 minus 3 is negative 1. 21 minus 2 is 19 minus 5k. Okay. I'm going to add 5k to both sides. So it's going to be 10k. Add 1 to here. It's going to be 20. So k equals 2. So all I had to do was find the value of the pronumeral, so I found what k was. But if I was to plug, if I substitute k equals 2 into 5k plus 2, that means 10, that means 12. The third term is equal to 12. Yeah, this is just on the side. We didn't have to do that, but I just wanted to show you. All right. We want to find the 15th term of these sequences. Okay. So I'm going to use the formula that Tn is equal to the first term a plus n minus 1 d. Alright, so the first thing I need to find out is what d is. So here d would actually be 7 take away 4, which is 3. Okay, a is my first term, which is 4, and n in this situation is 15. Okay, so I want to find the 15th term. So the 15th term is equal to a, which is 4, plus n, which is 15 minus 1, so that's 14, times the common difference of 3. Plugging that into a calculator, 4 plus 14 times 3 is 46, and that's the 15th term. Okay, looking at this example, so we're going to find the difference. Well, the difference here is going to be 13 minus 8, which is 5. A in this situation is 8, and n still 15. We're asking for the 15th term. So the 15th term is a plus 15 minus 1, n minus 1, which is 14, times by d, which is 5. So 8 plus 14 times 5 is 78. Okay, so in this case, a is negative 3, n still will be 15, but d is going to be 2 minus negative 3, which gives me a positive 5. Okay, and so T15 will equal my first term, negative 3, plus 15 minus 1 is 14, D is 5, so negative 3 plus 14 times 5 is 67. We want to find the formula for the nth term of each sequence. So what we want to do in this point, we want to find the recurrence relation. We want to find how to figure out every other term based on what we have. Okay. So we know our first term, we know what a is. In this case, a equals 9. We can find what D is, because that's just going to be 17 take away 9, which is 8. Okay, now using the formula that we have in our formula sheet, right, using this, we can plug in here. So the nth term is going to be A, which is 9, plus n minus 1 D. Yeah, and we could write it as 9 plus 8 n minus 1. That's fine. Okay. Cool. All right. Let us look at this example. So here we've got A is equal to negative 21. The common difference is negative 17 minus negative 21, which is a positive 4. So in this situation, Tn is equal to negative 21 plus n minus 1 d, which is 4. So let's write it's 4n minus 1 minus 21. Yep. Negative 21 plus 4n minus 1. Okay. Once again, A in this situation is 3.2. D is 4.4 minus 3.2, which is 1.2. So in this situation, Tn is equal to 3.2 plus n minus 1 times 1.2. 3.2 plus 1.2 n minus 1. Okay. All right. Here's another example for which term 3, 7, 11 is equal to 111. Okay. So once again, A would be 3 and D would be 7 take away 3, which equals 4. So using our relationship, so we've got Tn equals to 3 plus n minus 1, 4, right? We know what the term is. We know that Tn has to equal 111. So 111 equals 3 plus 4n minus 4, just expanding that out. So 3 minus 4 is negative 1. Add 1 to that, we get 112. So we get divided by 4, we get 28. So therefore the 28th score, the 28th term, is equal to 111. Okay. Now we want to find, another example, we want to find if 270 is a term of the sequence. So that's A would be 3, D is 11 minus 3, which is 8. And we want to figure out is Tn equal to 270. Okay, so using our recurrence relation, that Tn equals 3 plus n minus 1 d. Let's see if 270 is equal to this. Plus 8n minus 8. 3 take away 8 is negative 5. Add 5 to this side. Divide it by 8. N equals 34.375. Now, because n is not a whole number, it's not an integer, therefore it is not the 270 is not a term. Yep. 270 is not a term of this sequence. Yeah, because that's the decimal. Because really, if you think about it, we have, that's 1, 2, 3, it'll be 4, 5, 6. We do not have the 1.2 second term. Yeah, we have whole numbers. All right, here's our last example. We want to show that root 3, root 12, and root 27 is an arithmetic sequence, and hence find the 50th term. So this is a show that question. So an arithmetic sequence will occur if, right, Tn minus Tn minus 1 equals D. Yeah. So we're going to let root 3 be T1, root 12 be T2, and root 27 be T3. Okay, so therefore D will be T2 minus T1 and T3 minus T2. So in this situation, we've got root 12 minus root 3, and in this situation we'll have root 27 minus root 12. So root 12 can be written as 2 root 3, and that will give us root 3, and 27 can be written as 3 root 3 minus 2 root 3. 3 root 3 minus 2 root 3 is equal to root 3. So D's are the same. So as T3 minus T2 is equal to T2 minus T1, which is equal to D, the sequence has a common difference of root 3. Okay, it's important that you show this part as well as this part. You just can't find the common difference of one term and expect that to be the same for everything. You have, for a show that question, you must show that it works more than once. Yeah. All right. So part B was hence find the 50th term. So A would be root 3. D we found to be also root 3. Okay. And now we want to find the 50th term. So T50 is equal to root 3 plus 50 minus 1 of the common difference of root 3. So that's going to be root 3 plus 49 root 3, which will be 50 root 3. Okay. And that's it. And then if we wanted it as a big term, so 50 squared times 3 would be root 7,500. And I'm only doing that so it looks similar to those questions, to the answer. All right, thank you very much. Good luck.